Now, another application of testing between two means is when we want to compare dependent samples. And there are two versions of this. We might want to do a before-after comparison, which is detailed in section 7.10.1. And in this case, I want to know whether or not there's an effect of a process that occurs between two time points. And so it involves the calculation of a standard error for dependent samples. It's different, so read this portion carefully and work through the examples. The hypotheses are represented in the following way. The null hypothesis states that the process produces no difference. There's no effect of time between time 1 and time 2. And the research hypothesis suggests that the process produces some type of difference. The second section, or the second application of this process, is called matched pairs. And this is a different application of the same test. The idea is that we want to test whether or not matched pairs differ on some outcome variables. So for example, if I want to know whether or not twins are similar in intelligence levels, I'd do a matched pairs t-test. If I wanted to know whether or not siblings have similar personalities, I do a matched pair t-test. If I wanted to know whether or not assembly pairs on a line have differences in hand-eye coordination because they're so used to working with each other, that would be a comparison of a dependent sample. The calculations are detailed in 7.10.2, but I do want to go over just a couple of the basics here. So we need eventually to run this test, this equation. Okay? Now this part doesn't change from last time. We still have a pre-test, we still have a post-test, and I just take the difference there. So this part of the ratio is identical to the technique that we learned before when we were testing two independent samples. But this portion is significantly different. Okay? We need to solve for the standard error of the mean differences, and in order to do that, we need to go through that 7.10.2 section to do that. But first we need to solve for the standard error of the differences. Okay, this is taken by taking the sum of the squared difference scores and dividing by n, and then we subtract the difference between the means squared. Okay, once I have this term, I plug it into this equation so that I can arrive at the standard error. Okay, remember this is the standard deviation. Okay, this is the standard error. Okay. And once I have this standard error, this is what I put into my denominator there. Okay. So if you run through the example, in particular the step-by-step illustration of the test for differences between means for matched pairs and for before and after statistics will be very helpful.